All right, these last three examples are going to be a little tricky, so we're going to remember some of our strategies. Here I've got the third root of 54 over the third root of 10. First thing I'm going to do, do the easy things first. Can you simplify 54 over 10? Well, actually you can, because 2 goes into both numbers, right? So 54 divided by 2 is 27. And 10 divided by 2 is 5. Okay, so really this is the cube root of 27 over 5. And again, I'm going to kind of split that up again. I've got the cube root of 27 over the cube root of 5. Now that I simplified it, I'm going to split it up again. Now, cube root of 27, I know what that is. 27 is a perfect cube number. That's 3, because 3 times 3 times 3 is 27. So 3 over cube root of 5. Okay, so I've kind of gone as far as I can without actually having to rationalize the denominator. Now is what we're going to have this new strategy. So remember in the past, when I had, say, if this was the square root of 5, I would just need to multiply by the square root of 5 again, so that square root of 5 squared would be equal to 5. To cancel out the radical symbol. Now, since the index is 3 here, so we have index 3, what we need is 3 factors of 5 underneath the root symbol. So we need 3 factors of 5. So I already have 1 factor of 5, right? So really, I'm going to need 2 more 5s. So we need 2 more factors of 5. Okay, so what I need to do is really multiply by the cube root of, I need 2 more 5s. You can write that as 5 times 5 if you like, or you could write it as 5 squared, or you could write it as 25. Okay. So again, cube root of 5 times 5 times 5. So now what happens is the denominator simplifies to just 5, because the cube root of 5 cubed is just 5. And now the numerator, got 3 on the outside, and now I have the cube root of 5 times 25, right? And I can't simplify that any further because there's no groups of 3 of the same factors in the number 25. So here it is, 3 times the cube root of 25 all over 5. All right, notice what we did here. Again, I'm just going to kind of take you through it. First thing looks like a big ugly mess, yuck. See if you can simplify the inside first, and anything else that you can kind of simplify quickly. So I did that. I got down to 3 over the cube root of 5. Then, because it's an index 3 radical, got to multiply by however many more of those factors you need underneath the radical to make the radical go away. So I needed 2 more 5s to make 3 altogether. All right? And then that gets rid of my radical underneath in the denominator, the fraction. All right, let's do the same strategy with this example. Square root of 128b all over square root of 8b. So again, do the easiest thing first. 128b over 8b. So think of it as being together underneath the same radical. The b's cancel. Let's see, does 8 go into 128? If that would just divide out nicely, that would be wonderful. Unfortunately, fortunately it does. So if I divide both by 8, 128 divided by 8 is 16. So I just get the square root of 16 in the numerator and the square root of 1 in the denominator. I don't even have to write it because it's just over 1. And the square root of 16, that's 4. So there are going to be some cases where it looks like you have to rationalize the denominator, but actually you don't because it simplifies nicely. All right, let's do our last example now. Square root of 3 plus 7 all over square root of 5 plus 1. All right, notice I've got 2 terms here in the denominator. So in order to rationalize that, I'm going to have to multiply by the conjugate. So all the same numbers, opposite operation in between them. And whatever you do to the top or bottom, you have to do to the top. And make sure you're multiplying this whole numerator times that thing. So I'm going to have to really distribute everything out. Okay, so far what do I have? Root 3 times root 5, that is root 15. Root 3 times negative 1, so that'll be minus 1 root 3. Don't have to write that 1 though. And then 7 times root 5, so that'll be plus 7 root 5. And then 7 times negative 1, so minus 7. Can I combine any of these things together? Nope. All over root 5 times root 5 is just 5. And now remember, those cross terms are going to cancel out, right? So I'll just show you again. That'll be minus root 5 plus root 5. Those are going to cancel out, so I'm not even going to write them down. And then 1 times negative 1 is minus 1. All right, writing down everything I've got. Root 15 minus root 3 plus 7 root 5 minus 7 all over 4. There's nothing more I can do to simplify this. So it might look like it's a little bit more ugly than what we had to start with. But these two expressions, they are equivalent. And this is technically simplified because we rationalized the denominator. Okay, I do want to go over one more time the strategies we use for each of the different types of radicals we simplified in section 9.4c. Okay. If it's a square root and you just have one term in the denominator, just multiply by that radical just once, because all you need is 2 of them to match and get rid of the radical for you. Okay? Now, if you have 2 terms in the denominator with a radical symbol, then you have to multiply by the conjugate. Multiply numerator and denominator by the conjugate of that denominator. And that will kill those 2 cross terms for you and leave you with no radical in the denominator. Also, if you are able to simplify the fraction first, sometimes you don't even need to rationalize any denominators if that happens. Okay? However, if you're dealing with a radical that has some index other than 2, you want to make sure that if you're rationalizing denominators there, you need 3 factors of the same kind in order to get rid of the radical symbol. So if this was the cube root of 5 in the denominator, I needed 2 more 5s to kill that radical symbol. Okay? Always try to simplify before you go and rationalize any denominators to try and make your life easier. All right, best of luck on your homework.